All right, today we are working on a 2007 Pontiac Grand Prix with the GM 3800 engine. Okay, and those of you that want to see the engine cover, that is what it looks like. Okay, because I know that's the first thing you see when they open the hood typically. And what it is, this is a no start condition. So owner says vehicle was driving down the road and just shut off, it wouldn't restart. So we checked all the basics. We checked spark. It's got great, nice blue spark. We shoved fuel down its throat by spraying starting fluid into the throttle body, and it kept backfiring out of the throttle body. Wouldn't run at all, just kept shooting fire out of the throttle body. Ran a compression test. It's got 120 PSI on all cylinders, which isn't fantastic for a motor like this, but it's good enough that it should run. And of course air, we have faith that it's getting air, I suppose. We also pulled the valve cover, which I have the lights off for a reason, you'll see in a minute. So you won't be able to see this real well. But we also pulled the valve cover off, and we watched the valves move, so we know the timing chain is still connected. It didn't just shear teeth or anything like that. So at this point we're thinking a few things. Could be crank position sensor, cam position sensor, or both. Unlikely, but it could be both at the same time, or it could be a slip timing chain. Owner believes it's a slip timing chain. We want to run some tests here to make sure before we rip the whole side of the engine apart. So what we've got here is the Snap-on Varus scan tool, and we're using the oscilloscope function. I'm going to back up here for a second. What we've done is we've connected this scope to the crank position sensor wire that plugs into the bottom of the ignition control module. It is going to be a yellow wire, okay? Hopefully you guys can see it there. Okay, so we used a T-pin, we pinned into that yellow wire with one side of our scope, and the other side of our scope, the other connection is just going to ground. So just going to the negative on the battery cable, okay? We did a cranking test. So have someone go in the vehicle and crank. Luckily, this scope is nice enough, or this machine's nice enough, that we're able to go back in time and actually review this. So we're gonna review this data from this crank position sensor here. Okay, so we had our assistant crank it, and I'm going to play it kind of fast because this is what you're going to see on your scope when you actually do this in real time, and then I'm going to replay it for you. So this is what you see. Say, okay, turn the key on, crank it, and you're going to see this. Okay, and then he shuts the engine off, or he turns the key off, stops cranking it, and then that goes away. So let's rewind now and take a little closer look at our crank position sensor. Okay. So here is where he starts turning the motor over, okay? Looks pretty standard, I guess. This is what you want to see. You want to see a square wave. So every time that crankshaft damper, one of those little magnets on the toner ring goes around, and I'm sorry, it's not a magnet, it actually interrupts a magnetic field, but every time one of those little spots on the toner ring spins and interrupts the magnetic field on the crank position sensor, you're going to see this square wave appear, okay? So that's a good thing, that's what we want to see. However, one thing I don't like is it's supposed to be a 50% duty cycle, so it interrupts the magnetic field on that crank position sensor for the same amount of time that it doesn't interrupt it. So what I don't like here, and let me get a pointer. There's our bolt. Okay. So our 3/8 bolt's going to show us this, but what I don't like here is this amount of time is not equal to this amount of time. So it tells me that our duty cycle might be off, or our sensor may be having some issues. Okay, this is clearly much shorter than that, right? And it's even short. This is even shorter than this one. So we're starting to get a little bit of a red flag here. Not enough that I'd say this sensor is toast, but I don't like it. Let's go forward another frame. Oh my gosh, now we're getting really small, right? Okay, even on this screen, we fit 1, 2, 3, 4, almost 5 square waves on the screen. And on the previous screen, we've got 3.5. So unless the engine's spinning faster as time goes on, which is not likely, the starter's going to heat up and lose efficiency, and the battery's going to slowly wear down. This should not be. Okay, there they get wide again, and then now they get real short. Okay, not good again. There's a little blip there. That's not what you want to see. Okay, but notice the size just keeps changing. And notice they're kind of noisy at the bottom, noisy at the top. Really ideally, you want to see a nice clean square wave, and that's not what this is. Now they're getting really narrow. 1, 2, 3, 4, 5, 6, 7, almost 8 full square waves in one screen view. And the time sweep here has not changed, notice. This is a good screenshot that really shows you, hey, we might have a problem. Pretty wide, right? Pretty narrow. Okay, and these are noisy, 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 noisy. That is not what we want to see. Especially this. Check this guy out. Look how noisy those are. All right. Okay, and then of course these are much wider because the engine was spinning down, right? So he lets off the starter motor right here, and the engine starts slowing down, but the key is still on, so the crank position sensor is still being active, so that's where you start getting these huge square waves, okay, because it's slowing down. Okay, and then we're done. One more thing before we end the video, we're going to modify the sweep on this so you can actually see this entire starting event in one screen. So we go to Setup, Sweep, and we're on 100 right now. Let's go 500. It doesn't want to let us do that. I think I'm going to have to go back out of here and stop the video.